Hello, in today's video we're going to be covering decimal multiplication. The good thing to remember about decimal multiplication is that we follow the same rules that we would use if we were just multiplying some whole numbers together. We just have to be careful with where we're going to place our decimal once we have our completed answer. In this first example, let's go ahead and multiply 8 times 5/10. So I went ahead and followed the same rules that we would use if we were going to add or subtract a decimal. I lined up my whole numbers together, and I have my decimals over here. If we were to add a decimal to this problem, it would look like this. One thing that we can do, I could go ahead and multiply this the way that it is written, but it would be much simpler if we go ahead and simplify this problem. When we multiply decimals, we really don't have to line up the decimals like we do with addition and subtraction. So let's go ahead and rewrite this, and we are going to write it like so. We're just going to do 8 times 0.5. That 0, we usually want that if you're going to show a decimal and an answer, but when we're multiplying here, we don't need to put it there. It's not adding any value to this problem. So let's go ahead and work through this. If we were to do 8 times 5, we know what 8 times 5 is. Okay, it's actually 40. Okay, 8 5s would be 40, or 5 8s would be 40. And we have our answer here. But our answer is not 40. We didn't multiply 8 times 5. We multiplied 8 times 5/10. The way that we're going to determine how many decimals that we need in our answer is we're going to count the number of places that are past the decimal, or digits that are past the decimal in our beginning problem. And if we look here, we only have one number, or one digit, that is behind our decimal, and that's this 5/10. So what we're going to do is we're going to move our decimal back into our problem. So I put my decimal down here where we would normally put a decimal, and we're going to move it back into our problem, and our answer is actually just 4. Now I'm going to math nerd out on you for a quick second here. If this doesn't make sense to you, don't even think about it. So in my original problem, I can see that this is 8 times 5/10. Okay, we could write 5/10 as a fraction, or we also know, or we might learn to know in the future, that 5/10 is actually half of 1. If we had another 5/10, we would make 1 whole. So this is actually 8 times 1/2. Okay, and we know how to multiply fractions. We've covered that earlier. And so when we multiply straight across the fractions here, we would get 8 over 2, which is equal to 4. All right, and this only works if you know the fractions, or the fraction equivalents of some of these decimals. In our second problem, we're going to work through 1 3/10 times 6 2/10. Both of these numbers have a decimal, so this changes things up potentially a little bit. Now, one of my first steps is always to rewrite this vertically, so I've gone ahead and done that. I got 1 3/10 times 6 2/10. I've just rewritten it in a different way. Before we begin this problem, I want to talk about the power of estimation when it comes to multiplying decimals. Let's go ahead and talk about this. Really, 1 3/10 is pretty darn close to just 1, and 6 2/10 is pretty close to just 6. If I were to estimate an answer for this problem, I would just be thinking, oh, it's pretty dang close to 1 times 6, which is 6. So my answer, when I do this correctly, I should be looking for something that's pretty close to this, or similar to 6. So with decimal multiplication, we're going to act like these decimals do not exist. Okay, so let's go ahead and do 2 times, or 3 times 2, which is 6. We're going to do 2 times 1, which is 2. We're going to worry about the decimals later. I'm not going to put a decimal right here. Okay, now we have to make sure that we put a placeholder 0 down here. We are moving. We're actually doing 6 times 3 now, instead of 2/10 times 3/10. So we have to make sure that we put a placeholder 0 down here. Okay, so 6 times 3 is 18. And remember, we have to make sure that we're keeping our work nice and neat so we know what numbers go with what. And then our last step here would be to do 6 times 1, and we have to remember to add in that 1 up here. So 6 times 1 is 6, plus 1 is 7. Okay, go ahead and add these straight down. 6 plus 0 is 6, 2 plus 8 is 10, carry 1 over, and we have 806. But that is not our answer. Remember, our answer, when we estimated earlier, it should be about 6. Okay, now, if we remember from the last problem, the way that we find out where our decimal goes in our answer is we're going to look up at how many decimals or how many digits there are behind the decimals in our problem. Well, here, this 3/10, that's 1 digit behind a decimal, and here we have 2/10, a second digit behind the decimal. So we have 2 digits behind the decimal, and that means that we need to move our decimal point back 2 places in our answer. And we would find that our answer is 8 600. Another thing that I just want to note really quickly here, why estimation is pretty good with this, is we can see that the answer was 6 here. If I were to mess up my decimal, so imagine that I came down here and I only moved my decimal point back 1 spot. If my answer here was 80 6/10, it would not make sense at all. That is, 80.6 would be way too big of an answer. So in review, let's talk about a few key points that we talked about today. One of these would be is that when we're multiplying numbers, we do not have to worry about if we have a 0 before like 5/10, we don't have to worry about that. And we also do not have to worry about lining up decimals in our multiplication problem. The next thing that we need to understand is that when we're multiplying these things, we have to make sure that we are keeping our work organized and nice and tidy so we know what we are multiplying by and what we need to do. This one wasn't too affected. But if we look at our second problem where we had to put a placeholder 0 down here, we need to make sure that we keep this organized so that we know that, okay, my 6 is being added to nothing or to 0, and my 2 is being added to 8. Okay, if I mess up any of this, I'm going to have my problem completely wrong. And the next thing that we need to note is the power of estimation. We just covered that right at the end of the video. But again, I need to be looking to see, okay, I know that my answer should be close to 6. I got 8 6/100, so that's pretty darn close. And the final thing that we need to remember is that we have to remember once we get our answer down here, once we've multiplied and pretended that these decimals really didn't even exist, I really don't even need to write them in my problem that I'm working on. But if I go back to my original problem, in this problem, there were 2 digits behind decimals, so that's why I moved my decimal point back 2 times, okay? If we were to say a hypothetical, okay, let's say that we had another number out here. So let's say we added a 3 to this problem. If I were to find the answer to this problem now, well, how many digits do I have behind decimals? I've got 1, 2, 3. So then I would be moving my decimal point back 1, 2, 3 times in my final answer. Take your knowledge of decimal multiplication. Do great things with it.